Okay, what is the function here, Monica? Oh, it doesn't matter about the letter, yeah. We want the range here. Let's use our technique and see what happens. Y equals root x squared minus 29x plus 198. Y squared equals x squared minus 29x plus 198. 0 equals x squared, 1, plus minus 29x plus 198 minus y squared, which is like a constant. When is this quadratic solvable? It's solvable when the discriminant is positive and when this is not 0, but it's never 0 because it's always 1. So we just require this. So that means b squared minus 4ac needs to be positive. What's 29 squared, please? $841 minus 2468 792, yeah, plus 4y squared. What's these two here now? Nice. 49 plus 4y squared bigger than or equal to 0. So that's 4y squared plus 0y plus 49 bigger than or equal to 0. So what's the solution here? Yeah. The solution is everything. No matter what the value of y, is this greater than 0? Yes. This is a positive. This is a positive. So always true. Always right. This means that I believe the range should be all values of y. Then what is it then? Oh, I didn't allow negatives. Okay. Because I forgot to consider something here. In the process of squaring, I have forgotten the plus. When I squared, I forgot I was throwing away a plus minus issue here. Where did I throw that away? Yeah, here. Going from here to here. A bit like, remember in the last example I said the discriminant should be positive and y is not 0, and I carried them down together. My mistake was I forgot on this step to say y bigger than 0, because y is equal to square root. If y is equal to square root, it can only be positive, because the square root only gives you positive numbers. So I should have carried this down as well to the end. And then when I put these together, I get this. I can include 0, can't I?
So how can that practice
It's easy to make mistakes, but students actually do really well in the exam on this question, because this is an example of some. It's unfortunate that the start of the chapter is for something that's quite hard. In fact, the later part of the chapter is quite easy compared to this. This, believe it or not, is the hardest part of the chapter. The whole of this chapter of functions. We are starting with the hardest part, finding the domain and the range, and then it actually gets easier. So actually, your impression of this is wrong. It's actually an easy chapter that is just backwards. The hard part's at the start. Yeah.
What is the minus 29 here?
So minus what?
B squared minus 4.
Oh, this? Is this?
Oh.
Just a K2.
Which one?
K.
2K?
And 1U.
That's okay. I did.
Okay, I'll tell you what. I feel like a tutorial's coming on now. So we'll do, because this lesson is difficult and important, we'll do more examples of these. So which one did you want, Jerry? 1U. We'll start from number 1, okay? So, 1U, where's that? Okay. Can you read it out to me, Jerry?
Y equals to x squared plus 26x minus plus 160.
And I want the domain or the range?
Domain.
Domain. So the domain, that means when is this allowed? When is this valid? For square roots, you need the inside to be positive.
And 0.
Or 0. Let me think. This is the only way I'll learn. 16 and 10.
Yeah.
Wow.
No, really, not wow. Really, not.
I mean, Johnson will do that.
Shocking.
No.
Minus 10, minus 16.
Yeah.
So x smaller than or equal minus 16, bigger than or equal minus 10.
Could you please check?
You don't want to say it's wrong because of what happened last time. Okay.
I believe myself.
Yeah, okay, let's see. What's this? This is domain and range. Where is that? Where is that? I don't see it. Oh, there it is. What?
No.
Step by step.
How many questions is this up from the bottom? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6.
College. Wonderful.
Wonderful indeed. Unless, let me just double check I didn't write anything wrong.
X will be minus.
Here?
No.
Minus 26. Jerry, you read it wrong to me. You said plus. It's minus.
What do you do?
Let's do it again.
Yes, I will do it again.
Still wrong.
Okay. Okay. Let's see.
Trust me.
Okay, I'm seeing it.
Don't trust your yeah? Trust me.
This is minus. Okay, so what's the numbers now? No, it can't still be 10, 16. Oh, the signs are different.
Yeah.
Oh, minus 10.
Minus 16.
Minus 16. So that's 16 and 10 here.
Yeah.
So it's just over here. So yeah, it's still it's still wrong. So it should be the domain is everything less than 10 and bigger than 16. Let me just fix that, please. Include 10?
Yeah, include 10.
Include 10 and include 16. Okay. That should have it all fixed up nicely. Thank you, Jerry. You were right this time.
Teacher, why you have to do it this way? Why don't you do like an answer sheet and then...
No, maths doesn't work so... You know from doing the coursework one, it's not easy to type maths in Word.
Teacher, that's still word.
What?
That's still language.
No, this is LaTeX language.
But this is difficult.
It's not too bad. Not too bad. Okay, thank you for finding that mistake there, Jerry. What is the next one we need to see? Is there anything else from number 1 we need to see?
No way.
Number 1 is okay? Yes?
Let's see, exponential one.
Yeah, I didn't do an exponential one. Which one? In number 1 or number 2, KJ?
Number 1.
No one F.
1f. What's the domain here for 1f? All real numbers. Simple. Because, is there any time there's a problem when you put a number into E? No. You can put any number into E. So, yeah. So it's fine. So the answer for it is all real numbers. All real numbers. No. Because you are forbidden from using negative numbers in log.
What is that?
Is there a ball?
Oh, you have ball in one. Wow. Oh, that is, I miss
What is this?
Sorry, Jerry, you've missed your chance, it seems.
1K.
2K.
1K. 1K?
2K.
And then don't worry, I'll do that one. 1K. What's the domain for 1K? Let's have a look. Okay. Whoops. Please read it out, but unlike Jerry, don't make a mistake. Go. Guys, look up, please. Guys, please.
X cubed. X squared. Minus 4x. Minus 12 over x
Wow. No.
Squared.
I got squared minus 5x plus 4.
Okay, let's factorize this. On the top, what do I get? 6 and 2? On the bottom?
We don't have to do
Just
Minus
let...
one,
No, we
minus
do
four.
have to do that.
We don't
Minus
have to.
1, minus
Because
4.
top is R, and we only have to calculate.
Give me a minute, please, Jerry, okay? X minus 4...
Minus 1.
X minus 1. Yeah. So, all real numbers except for 1 and 4. Yeah.
That is more time.
Okay, let me give you one to try.
And how about the range?
That's what they wanted, domain.
Yeah.
Where's question 1 we're
I
doing?
want range.
We'll get to
Range!
it. We'll get to it. Someone asked me for this one. Bruce asked me for this one, so he wanted to see it, okay? Jerry, I'm going to give you one to try.
Teacher, I know, this is only for X squared.
Okay, no, just let me give you one to try, okay?
Okay.
Well, this is for everybody. Give me the domain. Domain, yeah.
X don't equal 1. X don't equal 4.
Are you sure?
No, it's R exactly. Because the x minus 1 and x minus 1 are
Factorize the top and the bottom.
x minus 1 squared.
What do you got on the top? X minus 1 and...
X minus 1.
And what do you got on the bottom?
X minus 1 and x minus 1. So it's cancelled.
So what's the domain here?
Just 4.
R.
All real numbers except
Except
4. No, all real numbers except 1 and 4.
Yeah.
Why?
Still, because if it is 1, it's 0.
If it is 1, you can't cancel these because they're both 0.
Right.
But.
Okay, fine, Jerry. Fine. Jerry, I understand. You are right. You only need to look at the bottom. But for these problems, it is sometimes useful to see what's happening on the top.
We don't care.
But if you don't care, you don't care, and you don't need to do it.
All the time, also we have like lower.
That is helpful
Yeah.
to find range.
It's helpful to find the range, it could be, yeah.
Would you help me find?
Yeah, now let's have a look at a range, something like this, yeah. So you said which one here? Okay, right. Is it the same one as this?
No.
2K.
No.
Okay, give me the function.
Y equals x squared minus 4x minus 5 over x squared minus 4x plus 3.
Okay, and we want the range.
Yeah.
Can everybody watch this carefully, because this is the hardest type, okay? So step 1, make it as an equation equal to 0. Y equals x squared minus 4x minus 5 over x squared minus 4x plus 3. So that's yx squared minus 4yx plus 3y equals x squared minus 4x minus 5.
Yes, yes.
Y minus 1 x squared plus 4 minus 4y x plus 3y plus 5 equals 0. This is a quadratic. When is this quadratic solvable? It's solvable when the discriminant is bigger than or equal to 0. Right?
Yeah.
No.
No, but
You forgot to say, and y is not 1.
Oh, what?
yeah,
Yeah.
I did that too.
Okay, well, let's continue.
Yeah.
So we get,
Teacher,
yes.
why is the discriminant has to be bigger or equal to 0? Even if it is less, it still has the value y.
Oh, it doesn't. What are you talking about, dude?
I mean, even if
Shh. No, stop talking. Listen to me carefully. Look at this. What type of equation is this?
quadratic.
Quadratic. And I said treat y as a constant. So you are no longer allowed to think of y as being the y-axis. You need to look at this y and pretend it's like a k.
Okay. And?
It's a bit like the problems we did in semester 1, where I gave you these types of quadratics. Remember? And I would say something like, this quadratic has 2 real roots, find k.
Oh.
Do you remember this?
So it's like we have to find a way to solve x, not y.
You're still trying to solve for x,
Oh.
where y is a constant k. It's no longer representing the y-axis. Yeah? b squared minus 4ac should be positive, and of course let's remember this. 16 minus 32y plus 16y squared minus 12y squared, for goodness sake, minus 3y plus 5y is 2y, minus 4 is minus 8y, minus 20 needs to be bigger than 0. 4y squared minus 40y minus 36 bigger than or equal to 0. Y squared minus 10y minus 9 bigger than or equal to 0. Y minus 10y plus 1 bigger than or equal to 0. Y does not equal 1. Y needs to be, if I draw this, it's going to be from minus 1 to 10. So y must be less than or equal to minus 1, or y is big. Yes?
Is it right?
I have no idea.
No, I mean the 1 minus 10, 1 plus
Is it not?
Yeah.
2.
Oh, thank you.
That's
Minus 9. Still wrong. Does it have factors? But that makes it plus 9 when you multiply. Which means maybe my sign is wrong on the 36. Oh, goodness, no, I hope not.
Oh, isn't it the plus
16 minus 20 is not, thank you. It should be, give me a break. It should be minus 4, and then this is minus, wait, this is worse. What's my y? Minus 32 minus 8 is minus 40.
Yeah.
Okay, well obviously I made a mistake multiplying this out in my head. Y times 3y is 3y squared times 4 is minus 12y squared. Do I have that?
Yeah.
Yes. minus 3y plus 5y, 2y, times minus 4, minus 8y. 5 times minus 1, minus 5, times minus 4, plus 20.
Yeah, but I started 6.
Hold on. So, plus 36, plus 9. There we go.
Oh, very easy to make mistakes.
Very, very easy. Y minus 9, y minus 1, y does not equal 1. 1, 9. This part, y less than or equal to 1, y greater than or equal to 9, y does not equal 1. So that is y less than 1, y bigger than or equal to 9. So that is minus infinity to 1 union 9 to infinity. That's the answer.
Oh, so we don't have, we have
Told you it was a hard one.
So many mistakes.
Yeah.
I mean, it's not hard, it's used to like a
Basic.
calculation method.
Yeah.
Because I did.
Yes.
Yeah. Step by step.
Step by step.
Why not equal 1?
Because it cannot be.
If it was 1, it's then not a quadratic.
Yeah.
This is only if it's quadratic. So, yeah. Sit up, dude.
Calculation.
Hang on. No, there's still 4 minutes left.
Wow, okay.
It's
From number one.
4 minutes.
One more question from number one.
Okay.
One more question from number 1 if you need it.
1 is
Which one?
no,
No, the other one.
not so much time. 1 is not equal.
One B. One day.
Here, x not equals 1 or 3. Is that what you mean?
Yeah.
Yeah.
And
Only try sine or cosine. Oh.
or it's not so
What about n?
not used equal 1.
It's not there's not really any use in the 1 and the 3 here. Yeah. Yeah, that's only for the domain. This is for the range. What's 1z, Monica?
It's minus 8 cos 9x plus 2.
Plus 2?
Minus 6.
Minus 6? Okay. The domain equals that. It's on 2. That's not on 2.
So fast.
Wow.
Why?
You can put anything into cos. There's never a problem. Just like sine. Not true for tan. Because if you have tan x, you cannot put in 90. Because remember, tan is sine over cos. So then the domain means you can't use anything that might make it 0 here.
Okay.
Yeah?
I want to try local.
No. What's the log one? Log.
What's 16x
16x?
minus 16? It's too easy?
No, it's not. For log, you need 16x minus 16 to be positive. So x must be bigger than 1. That's the domain. Yeah.
I have a question.
This,
Why you don't say ln instead of log? Because that's ln. ln and log is it's same, but it's
in maths we never mean base 10 when we say log. So when a maths person says log, they always mean ln.
Yeah, so you're doing ln right now.
Yeah.
So why you already say log?
I just told you, because if I say log, I mean ln. Because there's no confusion in maths. This is not like chemistry. Because in chemistry, when you say log, you always mean base 10. In maths, when you say log, you always mean base e, which is ln. Yeah. In fact, let me put it like this. If you were in a maths class and your teacher wrote this on the board, they would mean this. If you were in a chemistry class and your teacher wrote this on the board, they would mean this. In my class, there's no confusion. I only ever care about base e. So when I say log, I always mean base e. This is normal for maths class. Yeah. The reason for this, of course, in chemistry is because you care about logs for calculating pH. In the computer science, wait guys, just before you go, in computer science class, if your teacher said log, they would not mean this or this. They would mean this. Yeah.
That's what I want to say. I think we
What?
adding number
Yeah, but for abbreviation, when the teacher says log, they always mean the base that's important for the class.
You understand?
What?